Hey, what's up everybody? Thank you guys all for joining me. So today's video is going to be on upgrading your 3D printer to 3 colors. The steps that I took to actually upgrade mine. Been obviously on YouTube and I've watched tons and tons and tons of videos. There's not too many like this one or with full detailed descriptions on how to upgrade. Some of the stuff that you're going to run into, some of the mistakes that you'll more than likely make, and how to fix those mistakes. I'm going to be leaving my mistakes in there so that way if you do happen to make these later, then you'll have a better understanding, I guess, on how to fix them, if that makes any sense. But anyway, like I said, there's not a whole lot of videos on upgrading to 3 colors in depth anyway, on like, hey, this is what you have to do this here, this is the pin that you're going to use, so on and so forth. So that's what we're going to do here today. So enough of the intro, we're going to go ahead and just jump right in. Alright, so the very first thing that I did, guys, I gathered all of my parts. You got to make sure you've got all your stuff ready when you are ready to go. I.e. not like, oh, I got all this, but I still got to wait for this part. So you start it and then, you know, your build goes on hold because you don't have the part. So make sure you got all your parts ready. First things first, you'll need the ramps kit. It's the ramps 2460, the ramps Mega 2460, and then it's got the LCD RepRap Smart Controller that came with this kit. They sent me 5 A4988 stepper drivers with the heat sinks. I've got a stepper expander ×2. I got that on the RepRap site, and I'll put that link in the description. But they've got several of those. There's the stepper expander 1, 2, and 3. I got stepper expander 2 because I wanted to, add 2 motors. So I wanted a total of 3, as you can tell. I bought 2 extra NEMA 17 stepper motors because the first one came with the very first kit that I got, so I had the other motors. And then there's some ribbon cabling there. I bought some extra DRV 8825 drivers because I wanted to, get the upgraded kind. Later on in the video, I didn't actually use those. I ended up buying some more A4988s because I thought I had an issue with the driver, which that wasn't the case, and I'll explain all that later. But then there's some Teflon tubing. As you can see, the little green connector. And then the very last but not least was my hot end. It is the THC01 3-in 1-out hot end, and that's what's going to give me my multiple colors. And then lastly, guys, you have your 3D printed parts. I actually made extras, so I printed these before I took it apart, of course. This is going to be the piece that holds the nozzle. Well, it's going to go like that. That's going to be one of the pieces that holds the nozzle. And then I have a custom made back plate for the Anet A8. And the holes, see, like these holes, the holes in it all match up for the Anet A8. And then I put these rails on here. So the reason that I have those little, I guess bars, if you want to call them bars or whatever, on that backing plate there, I made the backing plate adjustable. So that way when you put your little screws in, you can put the little screws in the side, and then of course the little nut on the other side of it. And then once you've done that, you tighten it down to where you want your nozzle on the bed. So that way, it just makes it kind of a little bit easier, I guess, if you've got a few things that are more adjustable, as opposed to you got something that's just static. So if I had a static spot and I got it wrong the first time, that would have been real bad. So I made it adjustable. I also made the BL Touch holder adjustable. So that way, once you get it on, if you need to make slight adjustments there instead of in the software, you can. So that way, the nozzle part, it's going to go just like this.
So the first thing I did, I installed the heatsink on the driver. I wanted to start, obviously small parts, get all my components put together, then we'll start the build. But the very first thing, you'll take it out of the styrofoam thing there, and then you will put the heatsink on the driver. That's that little chip. Well, the little metal deal will go on the chip. That's to help dissipate heat. After you get the heatsink on the drivers, I put the jumpers on the board, because that's those little small black things that come with it. I put those on the board. The jumpers, they're gonna go on the board underneath of the drivers. They're gonna go right here. The next step, guys, we are going to power the 5-volt rail. That's where all your auxiliary pins are. That's where your servo pins are. So you have to put a jumper to connect it, to give power to that rail. The 5-volt and the VCC connection. That way it's going to power that entire rail there for the aux, for the servo pins, and that's how you get power to that. All right, next step, after you've gotten the jumpers on the board, you are going to put the drivers in. And I say this with very careful consideration. Excuse me, I got heartburn. Pay attention to the orientation on the potentiometer, guys. That's a little silver looking, like with the Phillips head screw on it. With the A8, it's going to go away from the power. So where you plug your power in, that's going to go away from that. If you've got the DRV 8825s, those will go towards it. The easiest way to do it, to find out which way you want to orient them, because trust me, if you do this wrong, you could blow up your board. But easiest way to figure out the orientation of these drivers is flip them over and look on the bottom. It should all be listed, like step, direction, EN. Look for the EN pin on the bottom of your driver. Once you find that, orient that to the EN on the board, and that'll get you, safely installed there. Next, we'll be putting on the smart adapter. This comes with the kit. It goes with the smart controller. That is going to take up aux 3 and aux 4. I'm not sure if there's still like another available pin past aux 3 and aux 4, or in that bunch. I don't know, because they're covered by the smart adapter. But if there are, then you could always, if you needed to get to it, you can get to it from the bottom. No, maybe not. You can't get to it from the bottom side of the board. Never mind. Scratch that. I almost told you the wrong thing. Okay, so you're going to put the smart adapter on. Okay, you're going to put that on the ramps board. The next thing you'll do, because this covers aux 3 and aux 4, you're going to take the RepRap full graphic smart controller, you're going to flip it over. Okay, and you're going to take note of the slots on the back of it. It'll say EXP1, EXP2. You are going to match those accordingly. So you're going to make sure that you have gotten the ribbon cable, plugged in to the appropriate one, and then you match the appropriate one on the board, or on the ramps board. So EXP1, EXP2. Make sure you get those correctly. If you don't, I didn't get mine wrong the first time, so I don't know what it looks like if you don't get them right. But I'm assuming it's probably going to be fluttery or something like that. So if it's fluttery or not looking right, maybe flip them. That might help. That's if you've, of course, gotten it wrong. So the next will be a bit of a confusing, probably to some, little piece of material here, because when I started my journey, I was trying to figure out how to load another one in. I was like, well, surely there's got to be another, spot when you code these motors for them to, an actual spot for them. So I got looking around and I found this. It's on the RepRap site, and I'll put a link in the description to where I bought it. But they have Stepper Expander 1, they have Stepper Expander 2, and they have Stepper Expander 3. This one that you guys are looking at right here, it is Stepper Expander 2. Because again, I was going to do, the ramps has, 2 spots, E0 and E1, so I was going to do 4. You can actually, in theory, do 4 colors with this. And yeah, this is going to be the fun part. But anyway, so this is called the Stepper Expander. I'm going to put a link in the description. Basically, it's kind of self-explanatory, I guess. This ribbon that you see here, that I was going to start out with it, but when I went to put it into the board, I wasn't entirely sure what pins went where, or, in the wire, what was to what. So I used some individual jumper wires, is what I did, and I color coordinated them so that way it was easier for me as opposed to this ribbon wire here. But basically, as you could see right here in the little diagram, the shadow's in the way for the one, but it goes from right to left in order of orientation. Your top, it's going to be your 5 volts on the top. You've got your X1 DIR pin, you've got your X1 step pin, you've got your X1 enable pin, and then you've got your non-commission pin. The second row there will be the very first right to left is your ground pin. And then if you are adding an additional stepper motor, the second, or so a fourth one in total, because I hooked mine up a little different than this. I didn't use both expansion slots, but you got your ground, and then you got your X2 DIR, you've got your X2 step, and you've also got your X2 enable pin. Then you again have that non-commission pin. So starting from right to left, hook all those up, put you like a little jumper wire in each one of those other than the non-commission pin. Don't use that. So I use red for 5 volt, ground for ground, black for ground, and then I believe it's purple, yellow, and green maybe is the combination that I use for direction, step, and enable. But I used those purple because I had a bunch of them, so I wanted to use some of the wires that I had. But you'll put some pins, take those pins, you'll use those pins. I just used the X1, I didn't use X2. And then the X1 will go to, so the one that is closest to the power port is number 2. And so driver expansion slot number 2, and then driver expansion slot number 1 is the one that's by the diagram on this. Now the pins that I used to actually hook this up on my ramps board for the enable pin, which is far left there. For the enable pin, I put it on pin 20. That is going to be up towards where your in-stop pins are at. There's 20 and 21 that's there. I use pin 58 and pin 57. Both of those are on the aux 1. That's pin 58 is the step pin, and 57 is my direction pin. And then obviously I've got 5 volt and ground. But those are the pins that I used. They were open. You don't have to use those, but you're more than welcome to use any pin you want that's open, as long as it don't have like a pull down resistor on it. That was the problem with pin 21, I think. That's why I couldn't use pin 21, because of the pull down resistor. Also, on this board, you will need a 12 volt connection. There's a 12 volt connection on the ramps board that comes off the ramps board. There's 2 pins just below those 2 little yellow things close to the power port. it'll say 12 volt on it. The far right pin is the red pin, hot pin, and the one on the left is going to be your negative pin. So that way, if you hook them up backwards, that could cause you an issue. I didn't hook them up backwards, so I didn't have any issue there. But I want to make sure that you guys don't have an issue if, you know, while you're doing this. All right, and then obviously when you get your hot pins, it's going to go to the stepper expander board, the little blue slot. It's going to go in that little blue power connection terminal. Ground is labeled and VMOD is going to be positive, so that's how you do that. And just pop those in there coming off of your RAMS board. That's going to power it. And then you've got your pins that are going to go to your motors. It looks like 1A and 2B, 1A, 1B, 2A, 2B is what they look like. Now, I'll discuss that polarity portion in a second. That had me at my wit's end for I don't know how long. The 1A and 1B labeling, 2A and 2B labeling, very, very confusing. So I'll explain that kind of in depth, if you will, when we get closer to that part. All right, and then as I think I explained that in the beginning of the video, but I bought DRV 8825s when I bought the stepper expander. I was going to be using those, and it was just stuttery as all could be. So I couldn't figure out what was going on with the stuttery, so I thought it was the drivers that were doing that. So I bought some A4988s. I figured I'd just go basic, just like the rest of them. You know, just like the rest of the ones on the board. So, and I'm going to point out my mistakes with the motors. So, the problem with the wiring, or what I had going on, is if your motor is kind of stuttery like this, then more than likely, especially if you went through all the pins already and you double checked them, which I did, the problem, 1A and 1B, that's one circuit. I was trying to do them in the B's, so I was putting the A's together and the B's together, and it was making it do that stutter. The way you want to do it is you go by ones and twos. So 1, and then A and B, and then 2, A and B. And that's the complete circuit. Well, that'll be, because each one of those, doesn't matter the polarity as long as you've got both circuits connected right. So like your 1s and then your 2s, as long as they're connected right, it won't stutter like this. But I had it wired backwards. That's why it was doing that stuttering back and forth. And I've been in so many groups. I got a Discord just to get some help. I was in some of the RepRap forums. I've got stuff posted everywhere, and I couldn't figure out why this motor was going back and forth, back and forth, back and forth. But it was because I had one of the pins switched right there at the motor. So when you go to plug in, like the connector, you know, from your stepper expander board, and then you go to plug it into the motor, the connection, easiest way to say it, I guess, is when you're looking at one of the NEMA stepper motors, NEMA 17 motors, from the top down where the pins are at, if you go from the left side, the far left pin is one of the active pins, circuits on the motor. You skip 2, so 1, 2, and then that one that you skip, the third one that you didn't skip, that completes that circuit on that one side. So it'll be the far left pin, skip 2 pins, and then that pin after you've skipped 2, that'll be one circuit. And then if you go all the way to the right on the NEMA, still looking top down, far right, that pin's active, and then you skip 2 going back, you know, back towards the left, and then that third one, after you've skipped the 2, that's going to complete the circuit for that other motor. So it's I can't remember, bidirectional motor is what they call it. So each portion has to have 2 connections. So a hot and a black, or a red and black. So, or ground and positive, you know what I meant, and the polarities. So I'm a newbie too, so that way, I mean, you guys get another newbie building a 3D printer, I'm gonna make the same mistakes you guys are probably making, or call it the same stuff. But yeah, so that was what my problem was there. It was the wiring of the stepper motors.
Alright, so guys, as I'm editing this video, I caught the mistake that was giving me so much issues while I was trying to hook that motor up. So I wanted to put it on screen here for you. As you can see, A1 and A2, they've got it labeled by A's and B's. If you look at the diagram on the right, the one that I've corrected, that's how it's set on the ramps board. So if it's different, like this diagram is different than what is different on the ramps board. So I was following the ramps board, and I was doing it by A's and B's instead of going 1s and 2s. So that was what was throwing it off. So I put the correct one on the right. If you're running into any issues, if it's like stuttering and stuff like that, this is the one that I found online. The one on the left is the one I found online, and the one on the right is the corrections that I made to it. So yeah, that kind of just fixed it. I solved it.
Temp plugs. Okay, yeah. So then you'll plug in all the other stuff to your board. That's what I was meaning. So once you've gotten your drivers plugged in, you've gotten your jumpers put on, you've gotten the stepper expander wired up, you're going to plug in all the other components. So X, Y, Z, you know, the end stops. My end stops were already on from when I built my Anet. It was originally an Anet A8. It's now not an Anet A8. So yeah, I guess it's a Frankenstein 3D printer now. But you'll plug in your end stops. They're all going to go to min. So X min, Y min, Z min. Those will be the ones that you use. Your temp plugs, like so temp 1, bed temp, your fan plug. I've looped my power. So coming in, it's coming into, you know, the main power supply. You've got a 12 volt and you got a 5 volt. As you see here, I looped mine to, it goes into the 12 and I've looped it over to the 5. So that's how I've got mine hooked up. You can hook them up 2 different ways. I mean, you can go from your power supply, you know, run a second off the comm and because you got three channels down there that you can use that will supply power to your board. And you can put one into the 5 volt, one into the 12, but I just put one into the 12 and then ran jumper wires over to the 5. That's how I've got mine plugged up. I've got it extruder fan bed set up. So D8, 8 is my bed, 9 is my fan, and 10 is going to be my extruder on this plug here. Now, the important thing that I wanted to note too, going back to the end stops, because I might have mixed this up a little bit, but the important thing I wanted to note on the end stop is you're going to be hooking that up to the signal, okay? Because there's going to be, on your end stop, that's going to be min, max, so X min, X max, Y min, Y max, Z min, Z max. Now, on the mins, I believe all of them have, there's 3 pins there. So you've got the signal, and you've got ground, and then you've got hot. Where I was making a mistake at is I was trying to put it on ground and hot, and the pins weren't active, or the end stops weren't activating. You know, like it would just try to keep going. So I was like, oh, what's going on? You have to put that into the signal. So now we are going to be moving on to the BL Touch. The BL Touch is relatively straightforward. I mean, it seems kind of scary, but it's not. Again, a lot of mine was kind of set up from prior because I had the BL Touch on my Anet A8. So I mean, just adding it to the Ram Sport, it's just a little bit different. It's going to go on servo pin 11, and I'm going to show you how to do that here.
All right, so on this one, this is basically, we're going to be breaking down, I'm sorry, we're not breaking it down. We're installing the BL Touch, the carriage. This is a 3D printed carriage. I found the file, so I'll upload the file along with it. I had to kind of file it down a little bit, but it's totally cool. But basically, I installed the carriage first, and then, as you can see here, I'm going to be putting in the little screws that are going to hold the BL Touch in. And then I've got my wires already. They were hot glue. I put hot glue on them so that way it wouldn't like connect and be touching and all that kind of stuff. So this is the next spot, and I'll put the link. I'll put all my links in the description, so that way it'll take you guys to where the parts are at that you'll need to download, so that way you don't have to spend all that time designing or whatever. Because I actually combined a couple parts to make the back plate, and then again I combined a couple parts to make that BL Touch holder. So next will be the wiring diagram that I used to actually wire this up. You're going to have your black and white wires up by your end stop. It's going to go on the signal and the hot, and then you're going to have the brown, red, and yellow. Those are going to go down on your servo section. And you got to also make sure that your rail is powered. But anyway, I'm going to walk you through my settings that I have right now. We're going to start with the pins.ramps.h or pins_ramps.h. That's where you're going to be putting your pin in, like the pin number. So I've already moved over to pins.ramps.h. As you can see, go down through here to pins_ramps.h. This is where you want to be. I'll just click it again because I've already went down. But I've got the Ramps 1.4 board, so 1.4. On the normal Anet board, the servo pin that you needed was going to be pin number 7. But here, you have to define it as pin number 11, so that way there's no conflicts. Alright, and then I'll show you the rest of my... Oh yes, and then you're going to have to add your 2 motors. I'm sorry. So because your additional stepper motors are going to need pins. So I've got my, of course, X, Y, Z, and then there's the EO, so that's extruder 1, and then we have E1, which would be extruder 2. That's the very first one that I had, and then these are the additionals that I've added. So you'll have to copy a section, and then of course just change the numbers here, as far as whatever pin you're going to be using. So you'll change those to the correct pin out, whichever one you're going to be using. But there's E1, E2, so that's 2 additional drivers, so that's going to be controlling 3 stepper motors right there between here and here. Okay, and then this one, obviously I copied it, but I don't need it, so it's not defined or anything like that. It's grayed out. So those are the settings for the BL Touch and the additional motors. Now we're going to move over to the rest of the file, which is the configuration.h file. This is basically where all of your settings are at. And we'll go through all of mine, what I've got it set at. Alright, so serial port 0, my baud rate's 1500, my motherboard's 43, which would be the Ramps 1.3. Changed my machine name, custom machine name, because I run a small business, so it's my small business is Aerial Endeavors, based out of Springfield, Missouri. I only advertise on Facebook, so if you want to check out what I'm doing, you can go there, Aerial Endeavors on Facebook, and kind of check it all out. But that's my name of my company. This is the number of extruders I have. My filament is 1.75, like most of them. This is very, very important if you're running more than one nozzle or more than one motor, stepper motor. If you want it 3 in to coming out the same place, you'll have to come single nozzle. And then I wasn't sure if my pinout was correct, so I just went ahead and copied it. These are the actual pins that I'm using: 57, 58, and 20. 20 pin is up towards the top right of the ramps board if you're looking directly down at it. And then, of course, your 58 and 57, those are, I believe, either aux 1 or aux 2. It's on the aux, it's the aux pinouts, where I'm using the aux pins there. So those are the ones for the stepper motor. Okay. Don't have a multiplexer. Don't have a switching extruder. Don't have dual nozzle. Not parking it, or it's not a mixing extruder. It's just 3 in, 1 out. So we'll go past those. On my thermal settings, I had to set my temp sensor to 5. I picked it on this list. This 100K thermistor. I picked that because, number one, this one, for some odd reason, just simply wasn't working. I wasn't getting no heat readout or anything like that on my nozzle. So I had to put it to 5, and that fixed it. Did the temp sensor, my bed sensor, it's at 5. They're both dummy sensors, are the cheap ones, so they're basic. I didn't have anything special about those. All this stuff I didn't mess with. Min temps, those were all set when I got there. I don't do any PID temp tuning or anything like that. I just leave it be because I'm not too versed in the PID tuning yet. But these are your K values. I know if you mess with those, it's going to adjust a lot of stuff. Bed heating, we're not doing. I mean, we heat the bed, but I didn't mess with any of it. I did take this off, the cold extrusion and extrude min tip. Those I left on, so that way it wouldn't, spit out, like try to spit out a filament when it wasn't hot enough. So beforehand, though, I uncomment them so that way I can actually do the testing of the motors. Your thermal runaway protections, those should always be on. End stops, so I'm using the min, all ZY, X, Y, and Z min plugs. I'm not using the max. I don't need those because it's software for the max end stops, so I just use the software end stops on that. Here, when I decided to install the BL Touch the first time, I went through and looked at some videos and watched a ton of videos to try to make sure I got it right on my original ANET. So here are my settings there. Everything seems to be working fine. To be honest with you guys, I can't remember. I remember a guy saying this was supposed to be the same as, I thought this, but this hasn't affected anything. So if you're having issues with like the BL Touch and it's not working properly, this could be one of the culprits. Not entirely sure. Like I said, it was set up on my Anet A8 when I originally set it up. I just kind of copied some of my settings and then changed the pin out to 11 instead of 7. As far as the driver types, I set these EO, E1, E2. I didn't really need to because they default to A4988s. I tried the DRV 8825s at first, but I was having issues with those, so I decided to go just stock. I'll probably end up changing my drivers out again for the XYZ, so that way I can get the micro steps, because I do still have those DRV 88s, or 8825s. So I'll end up changing those out later, but I'm going to get me a resin printer first. Let's see, we'll keep on going. I don't use like the noise filter, movement settings. I'm not using any distinct E factors or anything like that. Step access per unit, didn't change any of these. Haven't changed acceleration or feed rate or none of that. I leave that be. The jerk, leave that be. Z-probe option, since I have the BL Touch, you have to definitively use this. Z-min probe uses Z-min and stop pin. That's where the signal pin's connected to, so whenever it hits, it obviously stops and goes back up. So it's doing what it's supposed to be doing. Let's see. Okay, and then here's where it's all, encoded. So you got to define the BL touch. You set it at the servo pin 11. If your screen, and I found this out later through other videos that I watched, but if your screen's like blinky, that smart screen you got, it was set on 400, but I changed my delay to 1, and that fixed the blink. There's videos out there that'll help you with the blink fixing. This is just more to kind of walk you guys all through my settings, what I did. And like I said, if you guys have questions, because, you know, obviously I didn't do this video in one sit down. It's been over several months, so some stuff I might forget to put in, but if I do, like I said, just ask in the comments. I'll answer it, because it'll remind me. And then, obviously, you have your offsets, okay? So if you've got your BL touch, mine's in front of my nozzle to the left. So if it's in front, your number's going to be negative. If it's going to be to the left, obviously it's also going to be negative. But if it's to the right or to the back, positive. Alright, and then right now mine is about 50 millimeters to the left of the nozzle. So I put it negative 50 so that way it can go, you know, all the way correctly to the end and so on and so forth. I'm not too far behind it, just a little bit, or in front of it. And then also it's just below it. So if your BL touch probe pin is just below your nozzle, you let it know how far you are, you know, so that way it can calculate where the bottom of the bed is. Okay, all these are just standards. Well, I've left them, haven't touched them. I did change my probe clearance because I wanted to, you know, I wanted at least 4 millimeters before it, you know, deployed the probe. These are, you know, just a few probe settings. If you want to go back, you can use some of these. If not, you know, I'll let you fine tune your machine. Alright, my print bed's 220 by 220. So as long as you got the bed size right. These are the travel limits. This is where it goes when it homes. So I'm set to negative 33 is where the end stop's at, negative 10 in the back. And then there's a software end stop collaboration, but I don't really mess with the software end stops. I don't have a filament runout sensor. With the bed leveling, I'm using auto bed leveling by linear. Just what I used at the beginning. Maybe I could change it up. Like I said, I haven't had a whole lot of time to be messing with stuff, so you know, I do what I can. I wanted my leveling to be a bit more accurate, so instead of 3 points, I've done 6, so it'll do 6 on each row. So there's 18 points that it probes instead of just the 9. Unified bed leveling, don't use. Mesh bedeling, I don't use. You gotta untick these because you'll have to have an option on your screen. So if you want to do it from the screen instead of computer, you'll have to unstick that, untick those, or uncomment. That's the appropriate term. I am using Z-Safe homing, so it goes to the middle, you know, and then, you know, if you've ever used Z-Safe homing, I like it, so I use it. Don't mess with any of the skew factors. I probably should, but I haven't. Hence why my bed's probably not all the way level, or I still get issues. That's why I haven't actually printed lately, because I got to dick with it before, you know, I actually print something. I always got to check the leveling. You figured that sensor would take that all away, but it doesn't. It's the cheap one. These are just like the fan, you know, auto fan kick-ons. I had to buy a new power unit too. I don't have the nozzle park feature set. I'm not using any of that. I'm not doing the clean because it's got a wipe and prime tower when you're in the slicer settings. Job print timer. Okay, LCD support. You'll have that. LCD English. Display chart. SD support. I've got this set on because I was thinking I might use if the power goes out, then it remembers where you were. But I haven't actually set all that up yet either. Speaker, LCD controllers. You do have to make sure you get the right LCD controller, because there's like 2 sections or 3 sections for that. I believe, yep, mine's a graphical LCD, so it's the RepRat Discount Full Smart Controller. So you want to make sure you're in the right section. So graphical LCDs, and then you have I2C and register LCDs. So you make sure you got the right one, otherwise it won't work. And then there was something else very, very important down here at the bottom that I wanted to show you. I believe it had something to do with the servos. Bear with me. I do have an LED strip on mine, but it's not wired in through this. It's wired directly into my power supply. And I got a toggle switch on it where I can turn it off and on. Okay, number of servos. This is what I wanted to put in here, so I wanted to touch on, because you are connected to the servo pin for your BL Touch. So you do have to put number of servos, however many you're using. And then I believe I put this delay in it. I don't remember. I think I just left that normal. We're going to touch on our advanced settings real quick too. Nothing there that I messed with. That's thermal protections. Yeah, auto temps. Fan, PWM fan. Yeah, I don't think I used any of these. And stop always on. If I'm going too fast for you guys, you can pause the video, but I'm just running through my settings. Yeah, see, and these are all, like, I haven't messed with anything in here, I don't think. Oh yeah, if you want to do your micro steps, this is where you would do those. And that's, I've got those drivers, the DRV8825s. So eventually I'll get to that, but I am going to be messing with a resin printer here pretty quick after the holidays. I'm getting one of those, so I'll be printing more with that. Oh yeah, so remember when I was telling you about SD support? This is that power loss recovery. You'd have to, of course, pick a pin. If it dies, it'll save to a memory card where you were, like your last known position, which I think's pretty dope. So if you want to fiddle around with that, you can. Sorry guys, my wife texted me. Give me 1 second. So that is all in the advanced section. Oh yeah, and this, because when you have multiple motors, you'll have to have one filament go up, and then the other one gets fed in. So that's your retract settings, like how much you want to pull out the other one, how fast you want the other one to come in, so on and so forth. I use the basics. They have one in the slicer too. These are if you use TMC drivers, which I don't. That's if you've got like a CNC machine with a laser. So, I mean, if any of you guys have already looked through most of this kind of stuff, this is, I mean, you've looked at it, Some of it may sound like Chinese or look like Chinese to you, but not until you need it is when you would really use it. But that, guys, is in a nutshell. That's all my configuration H. I can upload it too, more than likely. You can change a few things if you want, but I can upload a copy of it. Maybe Mediafire, I don't know yet. But we will get back with you. Okay guys, so last things to show you are the fan up front. That's going to be this. That's going to keep the nozzle cool. Where those 3 screws are, that's going to be where my parts cooling fan goes. I haven't put it on yet. Also, the other little deal there, I haven't turned them on, but there's some LED strips. There's the other set, and then I have one right up underneath the nozzle here, wired in. So those odd and ends. And then this is I had to make this box thing. It goes behind my printer. It's what holds my motors on. That way I got back pressure, and I'll explain the first one. The first design, they were sitting on top of this, and it was terrible. Didn't work. So yeah, I had to redesign that. So I thus came up with this box. See? Drilled holes, it's holding the motors, taped up one of the wires. There's the motors. Alright, and then as far as this little devil, the thing I wanted to touch on with that is this was actually wired up to my ramps board, this little fan right here. That was wired up to my ramps board, the 5-volt. I had to keep taking this damn thing apart because it kept jamming up in the middle. Turns out that 5-volt power supply was not enough to keep that little fan going, to keep that cool, because I got heat creep. So it would, the heat would get a little higher than what it was supposed to, and it would make the one that you're retracting string out, and when the other one went to go in, wasn't enough room, so it would jam up and I'd take it apart. I obviously haven't printed with my printer in a while because it is dusty. It's been, I think, 7 months now since I started the video. Alright, and then we have the slicer settings. So I'm going to just run through this briefly. The one thing I'm going to need to mention, in order to do the 3 colors, you're going to need the new slicer. It's eSlicer 1.4, I think. Let's check. No. Yes. New slicer. Okay, so I found it, I think, on GitHub or one of those download sites. I mean, just Google it, type in, slicer 1.4, and I, of course, targeted it. This is where you go to Slicer Manager, so you'll pick, add the new one right there, and then you can name it or whatever. And then once you name it, you gotta set a destination for it, which both of those are the destinations for it, so you browse to it and so on and so forth. So you'll do that, and then here's what it looks like. So it's under New Slicer, and then you can go to Configuration. Alright, and once you've got it all loaded and whatnot, you'll add your parts. I mean, you can, change up your, how you want it. These are all things that I've actually changed, solid layers, infill, how infill you want it, whether you're going to do a skirt or a brim, any support material, the speed of it, multiple extruders, and this is the wipe and prime tower that I use. Okay, I don't set these other extruders because I use Repetier host. It knows. So my slicer, this wipe and prime tower, that'll allow, like when you switch colors, it's going to spit off and clean off the nozzle, so get rid of all the one color, and then it'll pop in the new color, and then it'll prime it, so that way when it starts printing, you don't have like colors mixed and stuff. So that's the tower. I also have it set, let's see,
I'm just letting you guys take looks at my slicer settings here. Overlap, output options. That's if you want to do sequential printing, which we don't. There's dependencies, filament setting. If you've got fans, advanced, I got mine set to, there's your tool change parameters, like how fast it's going to unload and how fast it loads. Custom G code, so like if you've got, you know, at the start, you've got your end, and then I thought there was one with like tool changes and stuff. Maybe not. Oh yeah. And then the third setting, here's your general custom G code. This is where I was talking about. So like it'll let you customize this. So like between layers, if you want to run some different G code, you can do that. The end G code, I've got it set so whenever like it finishes the print, it's going to pull out that filament 50. So that way, whatever the last one it's using, so that way when you go to start a new print, you know, whatever motor you've got going, it'll, you know, load it up first and it won't jam up. That was a pain in the and then it auto bed levels, you know, homes all the accesses. And then if you wanted to do like some special codes before the layer changed and after it changed, and that'll do it to each one, which is dope AF. Tool change, so like if you've got, you know, like a, I don't know if you had it like a probe first, but CNC's really is, we'll use that. But let's see. Well, and this is like you know, before it changes. So yeah, so if you wanted it to do something specific, you know, before it changed, which you could always have, like write your own code here instead of using that wipe and prime tower. If you're a bit more advanced, you could write code in here for it to wipe and change. So that's all the like the custom stuff. And then, you know, between objects for sequential printing. So the new slicer is pretty sweet. And this is what I've got it all set. Nozzle height, retraction speed's 30. So whenever it pulls out, you know, filament, it's how fast. See, extruder motor, and then it cleans it while it wipes. So it's pretty dope. So that's going to pull back 52 millimeters, you know, when it changes the filament. And then I've got it push out 1 extra millimeter on start, so that way it kind of gets to that other shit pretty quick. I think I've got them all set pretty much the same on this. And then single extruder, multi-material parameters. So like if you've got, you know, you wanted to print with ABS and then maybe some flexible stuff on top, this is a section I believe you would use for that. And then there's notes, and then what it depends on. So that in a nutshell is the Slicer Prusa Edition 1.4. This is the only one that will actually print 3 colors. But here's, anyway, once you add an object, you'll add one, and then you can do these in AMFs too. I can't remember. Slice to SVG. I can't. Oh, wait. Right here. So if you've got multiple objects and you want to combine it into one, like if you do it in multiple parts, like you've got the arms this color and you got a body as another color, and you wanted to just, you know, be able to do it all at once, you would save it right here, like turn it into an AMF file, which is all 3 colors combined. And when you load it into the on here, yes, we're going to discard those changes, but when you load it onto here, it'll have your object placement, so it'll have your 3 different motors, and you'll see it once you load it. If you guys have any questions, I'll always answer. It may take me a while, I work a lot, but in a nutshell, that's how you do it. That's my slicer settings. If you're ever going to edit any of the G code, it's going to be right in here. If you want to, you know, change it out,
And then I don't have mine connected right now. It's not powered up. It's, you know, 2 o'clock in the morning, well, almost 2:30. So I'm not going to power it up, but it's, yeah, once you connect, it'll be able to, it'll give you all your arrows, say like your Z heights and feed rate, homes, left, right, forward and back, so on and so forth. And then, you know, your different colored motors would be right here, or your motors will be controlled right here, so you can change them. But that's it, guys. So, thanks a lot.
It sound right, boys. It sound right, boys.